Welcome to this explainer. Today, we're diving straight into a massive challenge in modern AI architecture, securing multi-agent systems beyond the traditional network perimeter. Look, if you're building autonomous agentic workflows, you already know the incredible power of collective intelligence. But you also know the terrifying risk when these autonomous entities interact at high velocities. So today, we're hitting the whiteboard to architect a real, robust solution.
We're guided today by the insights of cloud infrastructure and security architect Vivek Srivastava, and he drops an absolute bombshell right out of the gate. He argues that the firewall is dead for autonomous swarms. I know it sounds bold, right? But as we'll see, relying on a static, secure perimeter when your agents are constantly spanning runtimes, namespaces, and clouds, yeah, that's just a recipe for disaster. And that brings us to the ultimate question for today's session. How exactly do you secure a chaotic swarm of AI agents that are exchanging messages and executing tool calls at actual machine speed? It's kind of like trying to manage a hyper-busy restaurant kitchen where every single chef is moving at 1,000 miles an hour, constantly grabbing ingredients and shouting orders. A bigger, thicker firewall isn't going to cut it. The real fix, relentless, identity-centric verification on every single agent-to-agent interaction.
So here is our roadmap for systematically solving this. We'll start with the death of the perimeter, then build out our zero-trust intelligence framework through workload identity, authenticated transport, and explicit authorization. After that, we'll tackle neutralizing poison nodes, and finally wrap up with the resilient swarm future.
All right, part one, the death of the perimeter, and exactly why inside equals trusted has become a massive vulnerability. There is a fundamental architectural clash happening here. Traditional perimeter security completely relies on a stable boundary. You know the drill? It's that classic castle and moat model built for a small set of north-to-south entry points. But agent swarms? They absolutely shatter that model. They're generating immense volumes of high-frequency lateral east-west traffic. They're constantly chaining tool calls together, and they effortlessly span multiple runtimes. So, why does implicit trust totally fail us here? Well, first off, firewalls see packets. They do not see semantics. They literally cannot tell the difference between a totally benign agent request and a malicious tool abuse sequence, like, say, a retrieval that leads to a prompt injection, which then triggers a privileged action. Plus, if just one sub-agent gets compromised, implicitly trusting internal traffic means the attacker instantly inherits the swarm's entire tool access and data paths. We're talking about incredibly rapid, catastrophic lateral movement. To eliminate this threat, the control point has to shift entirely. We've got to stop guarding the moats and start verifying every single handshake. And we achieve this zero-trust intelligence through three core steps: establishing identity, securing authenticated transport, and enforcing explicit authorization. Moving right into step one, workload identity, which acts as the crucial identity ledger for autonomous entities. Look, once you stop trusting the network, the absolute foundational primitive you have to trust is identity. Instead of relying on broad, shared API keys, every single agent process needs its own unique, verifiable identity. This is exactly where frameworks like SPIFFE or decentralized identifiers, DIDs, come into play. Think of this like an unforgeable digital passport for every single agent process, firmly backed by asymmetric keys and continuous rotation. This gives you precise attribution and drastically shrinks your blast radius if things go sideways.
We really need to rethink how we handle secrets. We have to ditch static secrets entirely. Those shared API keys and anonymous internal callers, they need to be replaced with short-lived credentials. We're talking about OIDC-issued, scoped JWTs with incredibly strict time-to-live limits. In this model, rotation isn't an afterthought, it's a first-class, built-in operation.
Okay, on to step two, authenticated transport. We're talking verifiable handshakes and micro-segmentation.
Here's the golden rule. We have to treat every single inter-agent communication exactly like an untrusted external call. That means strictly enforcing mutual TLS, MTLS, typically through a service mesh. MTLS builds a secure, cryptographically verified tunnel. It's basically forcing agents to double-check each other's ID badges before they even whisper to each other, using per-request signatures to completely shut down tampering or replay attacks.
And right alongside MTLS, we absolutely need strict microsegmentation. You've got to trap your agents in constrained sandboxes, whether that's a namespace, a VM, or a container.
You aggressively restrict their egress, their access to secrets, and their data planes. The goal? Making sure each node can only reach the bare minimum set of services it needs to do its specific job, nothing more.
Which leads us perfectly into step 3, explicit authorization, where we enforce policy checks at runtime.
Because here's the thing, it is not enough to just know who is calling. We desperately need to know what they are actually allowed to do. By bringing in policy as code tools, like the Open Policy Agent, or OPA, we can swap out those clunky, coarse permissions for razor-sharp, narrow scopes. This gives us centralized, explicit authorization that evaluates the identity, the context, and the action in real time, right before allowing or denying any request. Let's break down a quick example of how this identity ledger works in practice. Before a receiver actually executes a tool call, it rigorously checks a series of claims. It verifies the signature and issuer for the workload subject. It makes sure the audience matches the destination service. It checks the specific scope against our policy as code. And it double-checks that the short time to live hasn't expired. It's incredibly thorough.
Moving to Section 5, neutralizing poisoned nodes. Because remember, zero trust inherently assumes a breach will happen.
Let's be real. Agents can and will be subverted. It might be a clever prompt injection, it might be a vulnerable tool, but it will happen. That's why an automated quarantine protocol is non-negotiable. You start by baselining your normal tool call graphs and access patterns. Then you set up alerts for behavioral outliers, like an agent suddenly trying to talk to a weird new destination or crossing a privilege boundary. The second that happens, the system has to instantly revoke credentials and sever those service mesh routes to isolate the runtime completely.
Beyond just isolating the node, we have to vigorously protect the swarm's collective intelligence. You see, the attack surface isn't just the agent, it's the coordination fabric itself, the shared memory, the messages. By demanding strict cryptographic provenance for every single piece of context, we effectively gate our shared memory and model updates. If we skip this, one untrusted input can easily cascade, and suddenly, the swarm's entire shared brain is compromised.
Finally, Section 6, the resilient swarm future, and engineering multi-cloud trust.
The real operational goal we're aiming for is to seamlessly scale these controls across the frameworks you're probably already using, things like LangGraph or AutoGen, without adding a ton of latency. How? By pushing identity issuance, MTLS, and your OPA policies all the way down to the workload layer. If you keep that verification local, like in a sidecar or a gateway, it stays blazingly fast.
So if you take away just one thing today, let it be Vivek's core insight. To unlock true enterprise-grade agent autonomy, the winning pattern simply isn't building a taller firewall. It's verifiable identity, it's authenticated transport, and it's least privilege authorization with continuous validation. We have to completely bypass perimeter defense to enforce granular, identity-centric microsegmentation.
As we wrap up this explainer, I want to leave you with a real challenge. When you sit down to map these controls onto your own production multi-agent framework, what are the first 3 changes you're going to make to deliver the absolute biggest risk reduction? How are you going to architect this relentless verification layer to harden your AI swarms? It's time to start ditching those shared secrets, map out your flows, and build actual verifiable trust. Thanks so much for joining me on this explainer, and hey, happy building!